Hello guys, in this video I am going to explain you the solution of this question number 75 of chapter 10 from the book Engineering Circuit Analysis by Hayt, Kemmerly and Durbin. So in this question, if you look at the circuit, so in the circuit you have all the impedances given, right? So means all the whether it is inductor, capacitor, all are in ohms, right? And the question says that it is given that IC is given that it is 1 angle 0 degree. So this is given, and we need to determine we need to draw a phasor diagram for V1, V2, Vs and Vr. So, and also we need to determine the ratio of V2 and V1, right? So over here, if you look at this, and since we know that when the circuit is represented with impedances, and impedances are treated exactly in the same way as we used to analyze the resistors. So over here this IC is given, right? So we can determine this voltage across the capacitor. So this VC, it will be IC into impedance, this impedance, right? Means XC. So IC is given as 1 angle 0 degree, and XC it is multiply with impedance is minus J, minus 4J, and we know that minus 4J, it can be represented as, in a phasor form, it will be 4 angle minus 90 degree, right? Sorry, yes, it is minus 90 degree. So substituting it over here, we get this into 4 angle minus 90 degree. So we get VC equals to 4 minus 90, 0 minus 90, 0 minus 90. So we get simply minus 90 degree. So this is our VC. Similarly, we can determine our V2, this V2, because same IC current is flowing through this. So V2 will be equals to IC into impedance is 2J. And we know that if it is 2J, then in phasor form it will be 90 degree, right? So IC it is given 1 angle 0 into 2J. 2J it is this, so it is 2 angle 90. So our V2, it is 2 angle 90 degree, 2 angle 90 degree volt. So this is our V2. Now similarly, if I want to determine VR, now VR, it is this VR, this 3 ohm, it is in parallel with this, right? So in this, the total impedance is, we have one impedance, it is 2J, another minus 4J. So the total impedance, it will be minus 4J plus 2J. So it is minus 2J. So total impedance is minus 2J, right? Total current flowing is, current flowing, it is IC. So it means that the total voltage drop across it will be like, let it be VR, right? Because this total voltage, whatever is dropped over here, it is same as this, because we are this 3 ohm and this total impedance, they are in parallel. So our VR, it will be this impedance of this circuit into current flowing through this circuit, which is IC, and IC is 1 angle 0, right? Now minus 2J, minus J is there, so it means it will be this, right? And 1 0. So it means this 2 into this one, it will give you 2, and this angle minus 90 plus 0, it will give you minus 90 volt. So our VR, it is 2 angle minus 90, right? Now after this VR, I need to determine the current IR. Let it be IR, right? IR. So if I determine IR, then our IR, it will be VR upon 3, right? Our VR, it is 2 angle minus 90 upon 3, so it is 0.667 angle minus 90 degree. So this is our amperes, right? Now once we get IR from this, we can determine this current. Let this current is I, right? So I will be equals to IC plus IR, right? Because the current is dividing. So our I will be equals to IC plus IR. So I will be equals to IC plus IR. Now IC, it is 1 angle 0. Our IR, it is 0.667 angle minus 90 degree. Now we know that if we want to add, then phasor, like addition in phasor, it is not easy, right? So we will convert it into the complex form, right? Complex number form. So this will be 1 plus j0 and this will be 0.667. So this will be our, just a minute, it is our minus 0.667 j. So in all we will get 1 minus 0.667 j, and now converting it into the polar form, we will get 1.2 angle. This conversion, like conversion from polar to complex number form and from complex to polar form, this you can do using the calculator, and also like you can use the mathematical formula also. Okay, just for a quick reference, like if we have, like if the complex number is this, then in polar form it can be represented as a square plus b square angle theta, and theta is equals to tan inverse b upon a, right? And this from polar form, like if we have this in the polar form, like if we have a angle theta, right, then this can be converted into a plus jb, where a will be equals to a cos theta and b will be equals to a sin theta. So simply you need to remember this formula, or you can do it using the calculator, right? So over here I got I. What is I? I is the current supplied by this voltage source, and the current that is flowing through 5 ohm. So if I is the current flowing through 5 ohm, so V1 will be I into 5, right? So our V1, it will be I into 5. So our I, it is 1.2, 1 point, right? And this 5 can be written as simply this. So it is 6 V1. So this is our V1, right? So, and now Vs, because we need Vs also. So what will be our Vs? Vs will be the voltage drop across 5 ohm and the voltage drop across this 3 ohm. So it will be Vs will be equals to this, Vs will be equals to this V1 plus Vr, right? So Vs will be equals to V1 plus Vr. So Vs is equals to V1 plus Vr, V1 it is 6 angle 33.7t plus VR is this, right? So 2 angle minus 90. And now since addition is there, so it's better to convert it into the rectangular or complex form. So this 6 this will be our, just a minute, so our V1, let me check what is V1. Okay, okay. So it will be 5 yes 5 minus 3.335J, and this plus 2 angle minus 90, it will be minus 2J, right? So this will be 5 minus 5.335J. So in polar form it will be 7.31, angle is 46.83. so this is our Vs, and it is in watt. So you can see how easily, with the help of the impedance, how easily we are able to get all the current and all the voltages in this circuit, right? Now coming to the question, we need to draw a phasor diagram that shows V1, V2, Vs and Vr, right? So to draw the phasor V1, V2 and Vs and Vr, so our V2 is this, our V2 is this, our V1 is this, our Vs is this, and Vr is this. So if I draw a phasor diagram for this one, so we know it is 0 degree, 90, minus 90 or 270, and it is 180, right? So first let me draw Vr, right? So Vr is 2 angle 90 degree. So this will be our Vr, right? This will be our Vr, 2 at angle minus 90 degree. So we need to draw Vr, yes. Then VL is 2 angle 90 degree. So this will be our VL, angle is 90 degree, right? Then after that V1 and V2. So V1 is 6 with angle minus 33.70. So it will be 6. So it will be somewhere over here. So this is V1, angle is 33.70, right? And then we need to draw Vs. Vs is this 7.31. So at angle 46. So it will be something like this, the longest one. So it is 46.83 degree, right? So it is our Vs, right? So V1, Vs, VL, Vr we have drawn in the over here, right? So this is the phasor diagram. Now the second part of the question says that we need to determine the ratio of V2 upon V1, right? So ratio of V2 upon V1, what is V2? Yes, V2 is this and V1 is this, right? Sorry, this is V2, not VL, it is V2, right? So it is V2. So V2 divided by V1, our V2 it is 2 angle 90, it is 2 angle 90, and our V1 it is this 6 angle minus 33. So simply we will get 1 by 3 angle will be 90 minus, okay, it is minus 90, so minus 33.70, so it is 1 by 3 angle minus 56.3. so this is the ratio. This same thing can also, this ratio can also be identified using the phasor diagram, but it will get it will be more complex, means you need a proper mathematics, vector calculations and vector representation. So over here I just determine the ratio using the formula, right? So with this I end this video. If you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.